Welcome back to the Savage Sullivan Math website. Today we're going to continue our journey with radicals. However, we're going to look at something called rationalizing the denominator. Ooh, sounds scary, but I promise it's really pretty simple. So when we look at something like this, which is just one of many types of rationalizing problems, this is kind of a level 1 one, and you'll see why I call it a level 1 once we start doing it. But when I have a whole fraction underneath a radical, that's really the same thing as saying radical 20 over radical 16. They mean the same thing. It's just easier sometimes to have the fraction under the whole square root. So we're going to go ahead and we're going to simplify what we know. For now, I'm going to just leave radical 20 as radical 20. But I'm going to go ahead because, wow, I know what the square root of 16 is. The square root of 16 is 4. Be careful that the 4 does not go under a radical. It is not radical 4, it is just a plain 4. So now when I look at this, I'm going to ask myself, okay, I don't have a radical in the denominator, which is good. We don't want that, which Mrs. Sullivan will talk about in a minute. But when I look at radical 20, I know that that's not simplified. So I want to go ahead and simplify radical 20. So over here, I'm going to go ahead and break it down like we normally do. So the biggest perfect square that goes into 20 is 4. So radical 4 times radical 5. Square root of 4 is 2. We cannot simplify 5, so we leave it as radical 5. So now I'm going to take this 2 radical 5 and I'm just going to replace it for the radical 20 because it's its simplified version. So I'm going to have 2 radical 5 over 4. Now again, we're going to just take a minute to look at our whole fraction and we're going to say, is the radicand simplified? Yes, it is. And then I look at my whole numbers, 2 and 4. What do I know about the fraction 2/4? It can be reduced. So I'm going to go ahead and I'm going to reduce the fraction 2/4. It's okay that 5 doesn't have a common factor with these two. We're not going to touch it because it's underneath the radical sign. So 2/4 we know is 1/2. So not touching that radical 5, we're going to leave it as radical 5 over 2. Remembering that this is really an imaginary 1 here. And again, I'm going to ask myself the same questions. Is my radicand simplified? Yep. Can I simplify anything further with this imaginary 1 and this 2 here? Nope. Is there a radical still in my denominator? Nope. Since the answer to all 3 of those questions is no, we are all set. So this is my answer to my problem.
This is quite the journey that we are on together. Rationalizing the denominator. Look at this second example that we have here. Again, we have a fraction in the radicand. The first step that you should do is split this fraction up. So you have radical 10 over radical 3. You can look at each of the radicands individually and think to yourself, can you simplify radical 10? No, 10 can break up into 2 and 5, but there aren't any pairs to squares there. Can you simplify radical 3? No, the prime 3 is prime, so there's nothing else you can do there. This problem is not done though because you have a radical in the denominator. You are not allowed to have a radical in the denominator when you have this in final simplest form. So we have to get rid of this radical 3. How do you get rid of a radical? Remember that a radical and a square can cancel each other out. So effectively, if we multiply radical 3 by itself, we can eliminate it. Now, if you're going to multiply the denominator by radical 3, you also have to multiply the numerator by radical 3. I mean, check this out. Radical 3 divided by radical 3, that's the same thing as saying 1. So it's okay to multiply a problem by 1 because it's not changing the integrity of the problem. So when you multiply fractions by each other, you multiply straight across. So radical 10 times a radical 3 is a radical 30. And then radical 3 times a radical 3 is radical 9. We know the square root of 9 is 3. So there we go. Okay, now we've rationalized the denominator. We need to just look at the numerator and make sure that that radicand is simplified all the way. So let's just check. Square root of 30 can break down into a radical 3 times a radical 10. And radical 10 can break down into a radical 2 times a radical 5. 3, 2, and 5. Any pairs that you could make into squares? No. So, here's our final answer. You did it. Great job. If you found this video helpful, please like and subscribe.